What's up, gamers? Dom the Madman here to bring to you our first ever CSSI instruction video. I hope everyone had a fantastic spring quarantine and are ready to take on this new class environment. Without further delay, let's get on with today's agenda. Today we're going to be covering object-oriented programming and classes. Many of you are coming from CS12, have taken it before, or have taken some equivalent course. With that being said, most of you should be relatively comfortable with the concept of OOP, or classes in general. But let's go ahead and do a recap. A couple key terms you guys should remember from the lecture are abstraction and encapsulation. Abstraction and encapsulation are two of four principles of OOP. With abstraction, we wish to design a system where we hide any of the unnecessary details that the user does not need to know or access. Another way to put it is that with extraction, we wish to build a public interface for private data. A good example for this is a car. When you start your car, you don't need to know all the nitty-gritty details of why your car moves when you push on the gas pedal. All you want to know is that if you want to move, you have to press on the gas pedal. Encapsulation, on the other hand, is where we bring together all the relevant pieces into a single class object. In other words, enclosing objects and functionality into one class. Going back to the car example, we know that the car is a complex piece of machinery, requiring multiple pieces functioning in tandem to provide a multitude of functionality. Now let's get to the bulk of today's video lesson, classes. Most of you should already be familiar with the concept of classes, but here's a good refresher just in case. Here are the key things that you need to remember to have in your classes when building them. Constructors, destructors, accessors or getters, and mutators or setters. Of course, there's more to classes than just this, but let's just begin with this as your refresher and use the ever so infamous rectangle example. I went ahead and created a new project in Visual Studio to show the physical code using the rectangle example. Let's start with our class. Recall that a class is made up of two pieces, a header file and a C++ file. We use the header file to hold the definitions we will be using for our class object. Now if you look at the top right left, you can see a pound pragma once. This is a preprocessor directive that is essentially the same as creating header guards like so. You can use the pragma once, but know that if you try to run your code on an older compiler, it's not guaranteed to work. Okay, so here we have our class and we want to have our constructors, our destructor, mutators, accessors, and more. If you guys recall, we have four kinds of constructors: default constructor, overloaded constructors, working constructor, and copy constructors. From here, I decided to save some space inside the CPP file and I used the initializer list. I also optimized the initializer list to funnel all the constructors' initializer lists into calling the working constructor. So as this calls the rectangle constructor with passing 0, 0, with filling the length and the width, which is right here. Likewise with the overloaded constructor, which passes a length and a 0, which essentially goes in here. And then the copy constructor, which also does the same and calls the working constructor to initialize it. By all means, these can be written in the CPP file, but I wanted to show you the often forgotten way of initializing objects. Next, we have our destructor. Remember that the destructor is written essentially the same way as our constructor, minus the fact that it has a tilde written before it. Know that the destructor is necessary when dealing with dynamic memory, and that generally our compilers create a default destructor, whether we write one or not. And it is always called whenever we free memory using the delete keyword or when we just go out of scope. For example, when we create an object inside a function, and then we leave it. Next, we have our mutators and setters, such as the set length and the set width. And this is where the abstraction comes in, as this is how we provide to the public interface for private data. It's not guaranteed that when we create an object, we're fine and content with the way that it's with the values it has, and sometimes we need to access it. So we need to make sure to create the proper mutators. Likewise with the accessors. We have get length, get width, get perimeter, get area, and a simple display function that displays them all. Now the difference here is that all of our accessors are also constant. And if you remember what constant does, it just makes sure that none of the data is changeable. So the only things these should be doing is either returning the data from our private section or just outputting data. Lastly, we can take a look at our .cpp file. Now the only thing you guys need to remember from here is that you need to make sure that you include the header file. The header file should always be included inside the CPP file and not the other way around. Secondly, you should also remember that when you write functions in your CPP file, you always need to resolve the scope of which function you're using, such as the display. In the CPP function, we don't simply say void display const. We need to verify that this is from the rectangle class.